Let's take a look at problem 3 from your lab assignment, section 6.2. They want us to find the volume of the solid obtained by rotating the region bounded by the specified lines or curves. We have y equals ln of 6x, y is equal to 4, y is equal to 5, x is equal to 0. So you should draw these things out. Drawing by hand would be a good exercise. Or you can just put them in a Desmos calculator. The ln function is this curvy function. We have y is equal to 4 and y is equal to 5 are horizontal lines, and x is equal to 0. So x is equal to 0 looks like it's going to be the x-axis. So let's draw those curves first. Y is equal to ln of 6x. And then y equals 4, y equals 5, and x equals 0. So what we have here is a space. There's this little space here between all those curves. Okay, so it looks like it's going to be this space over here. We got the ln function, we got the two horizontal lines, and we got the y-axis. So this is going to be the good candidate for the drawing. Now this is going to be spun around the y-axis. So imagine this spinning around the y-axis. We have the area is right flushed against the axis of rotation, so there's going to be no hole here. And it's going to be spun around. The outside is going to be this curved ln graph. So it's going to be the curved ln graph on the outside, no holes in the middle, being spun around. So I think it's going to be this choice right here. Okay. So let's go ahead and submit that and continue on with the calculations. Looks like we got that one correct. It would be good to rewrite this because we're going to integrate. If you see how the circles are going to get stacked up, they're going to get stacked up along the y-axis. Further, the radius of this disk that we're looking at is going to be a distance from the axis of rotation, the y-axis, out here, which is an x value. So we're going to need to solve for x here in this equation. So we take the e of both sides. This is going to be 6x is equal to e to the y, and then you divide by 6. So it's going to be 1 over 6 times e to the y power. Because we're going to also integrate with respect to y. We're moving along the y-axis. We're going to integrate with respect to y. We want to make sure that our function or radius is going to be in terms of y. So this is going to be the radius. It's going to go from the axis of rotation to that x value. X is equal to 1/6y. So that's going to be your radius. I'm just going to rewrite this as e to the y divided by 6. And then now the cross-sectional area of this is going to be pi r squared again. And then when r is equal to this, the cross-sectional area is going to be pi, and then this thing is r. So that's 1/6 e to the y squared. Now we could probably square this, so that's going to be pi over 36 e to the 2y, which is probably what they're going to end up with because they like to simplify things. And the simplified version might look a little bit nicer and neater to deal with. Or maybe they didn't simplify it and they just left it as it was. Alright, now rotating this around, we're going to go from A to B or C to D. And if we go look at this graph again, it's going to start at 4, the smallest disk, and then we get higher and higher. We're going to end up at 5. So the upper limit's going to be 5. And then we'll go ahead and do the calculations. 1 over 36 is a constant, pi is a constant, we just have e to the y, and the antiderivative of e to the y is e to the y, and we want to evaluate this at 5 and 4. Well, it's just going to be 1 over 36 and then pi, and then we're going to get e to the 5th power minus e to the 4th power. And I don't know if there's much simplifying after that. We can't combine these e's because they have separate powers. So let's go ahead and submit. Oops, it didn't look like it took it. Oh, this is supposed to be a, sorry, this is supposed to be a e to the 2y. So let's go 2y here. And the antiderivative of that after u substitution is going to be a 1/2 e to the 2y. And then now let's see, let's double 36. I think that's 72. And then each of these things will get doubled. That's e to the 10th minus e to the 8th. All right, hopefully that'll work. And it did. So that's good.